Well, greetings. This is Mr. Kolazar, and I'm going to be your chemistry teacher for this year. One of the things that we're going to be doing throughout the year are called flipped camera or flipped classroom videos, and what we're going to be looking at is having some of the lecture and some of the introductions to laboratories done outside of class. So inside class we can actually work on the problems and work through a lot more labs and get a lot more information covered, a lot more hands-on work. Throughout the year we're going to be seeing these videos. One of the nice benefits of the video is you can pause the video, you can rewind the video, you can stop the video. So as we're going, they will always be available for you for review at any time as we're working. So to begin this year, our introduction to chemistry actually deals with the introduction to chemistry. So as we're going, one of the things we're going to look at is to define and actually explain what chemistry is. Now in chemistry, we're going to break it down to chem is try, is one of our sayings we have in chemistry. And the idea is that you're going to have a little bit more effort into this class in order to be successful, but as we're going to make sure that you are successful in all that we work through. Now chemistry is going to be the study of matter and the changes it undergoes. That's going to be our first key definition. Now anytime as we're going during the videos, if you need to pause to stop in order to put the definition and information into the notes, please do so. Anytime you need to rewind and go back over a problem, remember they'll always be available for you to look back into. So with chemistry, it's going to be this year the study of matter and the changes it undergoes. Give you a hint, you'll see that as a test question more than once throughout this year. Now what matter is anything that has mass and takes up space. So basically all matter is just basically made up of atoms, molecules, any material that you can think of is matter. And we're going to be studying the changes of that matter and anything that it undergoes. One definition for matter, or part of it, is called a substance. Substance we'll also know as chemicals. So anytime we have a substance or a chemical defined during class, it's matter that has a definite, uniform composition, meaning it's the same throughout. So materials that are the same throughout are substance. If you have a pile of salt, if you take 1 gram of salt or grain from that salt or a whole bunch of it, it's still salt. So as a definite composition of NaCl would be an example there. Two other terms to discuss with matter is going to be mass and weight. Now what we're looking for is that both reflect the amount of matter. So mass and weight both similar by the effect that it's the amount of matter in the substance, basically how many atoms we have there. Now mass is independent of gravity, meaning it does not matter the gravitational pull, the amount of matter is still the same. Weight, however, is a reflection on the pull of gravity. Now, with weight, it kind of reminds you of the bathroom scale. When you step on the bathroom scale, the force of gravity pulls you down, pushing against that spring scale, and that spring scale turns a dial to show you how much you weigh. That deals with the force of gravity pulling down on an object. So an example here, we have a cartoon character on Earth who would weigh 100 kilograms. That same cartoon character person would weigh only about 16.6 kilograms on the moon. It's approximately 1/6 of the weight between the moon and the Earth. The mass of the two characters is still the same. They have the same amount of atoms or material that make them up. Gravity, however, is much less on the moon, so the person weighs much less on the moon. So an example of this would be much easier to slam dunk a basketball on the moon. You'd probably actually worried about jumping over the hoop, not just dunking the basketball. Other big term for this chapter is going to be looking at our different types of observations. Macro versus microscopic observations. Macro is going to be our large scale. That's going to be things that are visible to us that we can touch or see. Microscopic instrument we need for that is our microscope. Microscopic would deal with looking at like cells and smaller things there. Things that might not be visible to the human eye are going to be on the microscopic. Now, what happens on the microscopic scale affects what happens on the macroscopic scale. Now, going one step further, we can go even further than the microscopic scale. And that's going to be the atomic level. We'll know this a lot of times as the sub-microscopic level, meaning below or smaller than the microscopic level. One of the things that we're interested in is how matter behaves at this level affects the microscopic and the macroscopic layer. So as we're going, picture down in the corner here is showing an atomic force microscope picture of a bunch of atoms organized in a row, and actually we're looking at the electron fields around each of the atoms is what the instrument is measuring. But our focus is at the atomic level affects what happens at the micro and macroscopic level. So studying the atoms and molecules is going to be at that level, affects what happens overall. The structure, composition, or behavior of all matter can be explained on the submicroscopic, or as we were saying, the atomic level. All that we observe about matter depends on the atoms and the changes that they undergo. Chemistry seeks to explain the submicroscopic events that lead to macroscopic observations. One way to do this is by making a model. Now, models we're going to use a lot this year in chemistry, and what we're looking at for models are a visual, verbal, or mathematical representation of a submicroscopic event. Now, many models will take place on either large or small scale. Large scale could be like a map or a globe. Small scale, a lot of times in here we'll be dealing with the small scale, that submicroscopic level or that atomic level. So an example for that for today to finish out will be ozone. Now, ozone is a very important material in the atmosphere. It blocks ultraviolet radiation from entering our Earth and keeping us safe from things like skin cancer. Chlorofluorocarbons, a very useful material, were found unfortunately to have a devastating effect on the ozone layer. And so here's a chemical model demonstration. We have chlorofluorocarbons, CFC, will break down into chlorofluorocarbon plus one chlorine free radical. This chlorine is highly reactive, and when it finds an ozone molecule, it will attach itself, breaking off an oxygen O2 molecule and one chlorine and oxygen molecule. Now, from here, it breaks back apart, releasing oxygen and chlorine, and that free radical chlorine is able to come back around and attack another ozone, and it chemically will break that ozone down into oxygen, finding another ozone molecule, breaking it down to oxygen. So in the end, one CFC, or one chlorofluorocarbon, is able to destroy many ozone molecules. And the reason why we don't use chlorofluorocarbons anymore is because of the amount of ozone that is destroyed. Thank you for listening to Chapter 1's video. We will see you in class.